Okay, here's the results of my artificial blood vessel discovery findings. So first of all, I was required to design an artificial blood vessel, ultimately choosing the material that would be used as the walls of the blood vessel. So three biocompatible materials that I found that would work for an artificial blood vessel is first titanium, and then we have PET, polyethylene terephthalate, and then lastly, silicone rubber. All three of these materials meet the requirements in the body to that like the body would accept and not reject and cause infection. Here is a SolidWorks drawing resembling the shape of the artificial blood vessel. So first we have the average internal diameter of a male blood vessel of 3.57 millimeters, and then with a wall thickness of around a half a millimeter. And in this case, this is a 100 millimeter long blood vessel that we would be providing. Here's a fluid simulation that was done to acquire the internal pressure that from the blood flow through the artificial blood vessel. So first, the boundary conditions that were applied were the fluid flow at one end and atmospheric pressure at the other end. And then by using a surface parameter of the internal wall, I was able to gather the maximum pressure. Once this maximum pressure was acquired, this was used and inputted into a static simulation. Inside the wall is where the maximum internal pressure was applied. And then on one side, the edges were fixed to not move axially and no rotation. So from here, I was able to get the maximum stress that was outputted onto the walls of the blood vessel. Using this could be compared to the ultimate tensile strength and yield strength to see if the material would hold up to the stresses that was applied. Ultimately, after all this testing, the material that I think would be best to move forward with is the PET, because first of all, it's biocompatible. It has the lowest cost of material compared to the other two at $1.47 per kilogram. And then it also has the lowest cost per volume. Since the PET is very light, it makes it very affordable for the amount that would be used to make a blood vessel. And then since it met the standards of stresses, it had a factor of safety of 66, which is very large, but in comparison to the others, the titanium was much higher and the silicone rubber was just above 6. So this was a happy medium of plenty of safety, but then also not overkill. But since the cost was so low, it made sense and it was a good choice. And then here are my references. Thank you very much.